Hello and welcome back. I'm Matt with Schematical, and today I'm going to talk to you guys about neural nets for people without expensive degrees. So I'm fairly self-taught in this whole thing, and the field of AI is moving incredibly quickly, and I just wanted to throw out this because a lot of people ask me, hey, how do you know so much about AI? And I don't know nearly as much as a lot of people. I just know enough to make little Minecraft bots run around and do whatever it is they do in there. But I wanted to create a short little quick tutorial for anybody that wanted like a for dummies look into artificial intelligence and neural networks. So that's what this is. Probably seen a neural net before, just a diagram depicting one. It's got its inputs, it's got its outputs, and it's got its connector nodes that connect the inputs and the outputs. Now what does this all mean? When I was working on Chaoscraft, which is my experiment where I tried to use AI to teach bots how to play Minecraft, we used neural networks to train and allow them to play and beat Minecraft. They actually haven't beat it yet, but they've placed crafting tables and done a lot of other weird stuff. That was really complex, so let's start off with a simpler example. Tic-tac-toe. The first thing we need to think about is the inputs, or what the bot actually sees and uses. So in this case, we've got a grid, and we want to flatten out that grid because it doesn't actually see in 3 dimensions. It processes things in 1 dimension, actually. So here we take the 3x3 grid and make each row into 1 row by combining all 3 together. So instead of having a 3x3 grid, we have 9 inputs. Now those 9 inputs can actually have one of 3 states. There could be nothing there, there could be an X there, or there could be an O there. So we don't really need to know if there's nothing. We just assume if there's no X's and there's no O's, there's nothing. But if there is an X there, then we need to know that, and if there's an O there, then we need to know that. So it actually makes it so instead of 9 inputs, we have a total of 18 inputs. And those inputs activate when there's an O or an X in its corresponding spot. So you can see the top leftmost hand corner, 0, 0 position, has an O in it. So the first position input has been activated. And that means that the value of it, which is normally between -1 and 1, or between 0 and 1, would pretty much just become 1. And all the other ones next to it would be 0, except the fourth one, because the fourth one is also corresponding with the first row second column. And that has an O in it. Same with the X's. Now, all the inputs are connected to most of the outputs with the middle connector nodes, neurons, as you will. We'll explain how those connector nodes get there in a minute. For now, let's just review their function. Each one of those connector nodes has a value associated with it. Oftentimes between 0 and 1, but it can be a lot of different things depending on how you have it set up. That value basically gets multiplied by the input value. So if the input value is -1, and the node value, connector node, is 0.1, then it'd be -0.1. Now when that value becomes activated, like when there's an X or an O in the designated spot associated with the input, then that value becomes 1, often, or whatever the value spectrum is. Now the value of the output function actually has to do with all the different connector neurons that are connected to it. So it sums those up and uses this magical activator function, which I'm going to kind of just skip over here, but you can just Google activator functions. And it does some math to determine what the value of the output function is. Now, if that value doesn't have to be just true or false, but in this case for tic-tac-toe it is. It's just, does it want to put this, an X or whatever the symbol its team designation is, out on that spot, or doesn't it? Pretty simple stuff. You'd probably take the highest value from all 9 of the output potential nodes and use that as what your next move would be. If you were doing a racing game or something where you had a scale of a controller, like how fast you want to go or how much you want to turn left or right, then you'd use the more specific value. It wouldn't be so true or false, a Boolean. So that's basically how a neural net works, but there's more to it. We can't often get the decisions we really want for complex recognition, facial recognition, playing video games, whatever it is, just those 2 dimensions there. The inputs map directly to the outputs. So we add a layer of middle neurons frequently. Middle neurons do all the same calculations that we did for the first layer, but instead of passing it directly to the output, it passes it to another layer, which takes those input values and passes them to the final output layer as the actual values. So the same math applies here. We can do it with more than one layer, like this. It's very common to have multiple layers, therefore the name deep learning or convolutional neural networks. Now that we have a basic understanding about how neural networks work, we can take a look at some more complex ways of using neural networks. For example, image recognition. Image recognition is very similar to the tic-tac-toe grid, but instead of determining if there's an X or an O, you use RGB values, red, green, and blue. So you split up the entire image into a bitmap, a grid, and you use the values of how much blue there's saturated in it, how much green, how much red. Since there are a lot of grids in games, we can use a similar technique for games. So if you followed the Luigi.io project or the Mario project, you can see that they use a grid to determine what the floor is, where there's enemies at, and they feed that grid into a more complex neural network than our tic-tac-toe one. And then the outputs are up, down, left, right, and A and B, so jump and shoot a fireball. That can be done with a lot of games from the early half of the 90s. As I said earlier, it's a bit more complex with Minecraft. So that's the basics of how a neural net functions. There's obviously a lot more that goes into it, like how do we train them? How do we teach them to actually recognize faces? There are a couple different ways, and I'll save that for another video. If you do like this style of video, please comment and let me know, or hop on the Discord. I'm happy to do more of these if that's what people want. This is a little too basic for you guys, let me know too. I appreciate all the feedback and support, especially for those of you guys from my Patreon subscribers and those of you guys in the Discord community. So with that said, thanks, and I'll have more videos up soon. Why does this need to be so close to my mouth? It's gotta be like inside my mouth. Why?